Hi everyone, in today's lesson we are looking at Chapter 8, Section 7, Dilations. Our objectives are to identify dilations and use properties of dilations in real life. One thing to know about dilations is that dilations are not rigid transformations and therefore they are not isometry. The reason why they are not rigid transformations is because they actually increase or decrease in size, so the size does not stay the same. Let's start with some definitions. First definition is dilation. A dilation with center C and scale factor K is a transformation that maps every point P in the plane to a point P so that the following properties are true. If P is not the center point C, then the image point P prime lies on the ray CP. The scale factor K is a positive number such that K is equal to CP prime over CP and K is not equal to 1. And 2, if P is the center point C, then P is equal to P prime. Enlargement is a dilation where the scale factor K is greater than 1, and reduction is a dilation where K is greater than 0 but less than 1. Example 1, identifying dilations. Looking at A, my original or pre-image is this triangle right over here. And I know it's the original because it just has P as opposed to P prime. My image after dilation is this triangle over here. And I know it is the image because it has the prime over here. Looking from the blue triangle to the red triangle, I've actually decreased the size, which means this has to be a reduction, and I know that my scale factor has to be less than 1 if it is a reduction. To find the scale factor, there is a ratio that was in the definitions. Basically what you're going to do is you're going to take C to P prime and put it over C to P. And so C to P prime is 3, C to P is 5, so our scale factor is 3/5. And because our scale factor is less than 1, this is a reduction. Looking at problem B, here is our original image. I know it's my original because it doesn't have the prime next to it. Here is my image after transformation, and I know that it is after transformation because of the fact that I have the prime over there. Looking from my original to my new transform image, I can tell that it has gotten bigger. So this is an enlargement. And again, I know that since it's an enlargement, the scale factor has to be greater than 1. So when I'm writing the scale factor, I'm going to go from C to P prime, which is 12, and put that over my C to P, which is 5. So I get 12 over 5. Therefore, my scale factor is 12 over 5, which I know is greater than 1, so this is an enlargement. Example number 2, dilations in a coordinate plane. Draw a dilation of triangle XYZ. Use the origin as the center and use a scale factor of 2. Find the perimeter of the pre-image and the perimeter of the image. Let's start by doing the dilation. First thing we need to do with the dilation, whenever we have a dilation, it means that we are multiplying each coordinate point by the scale factor. So because the center of the dilation is the origin, you can find the image of each vertex by multiplying its coordinates by the scale factor. First, let's go ahead and draw our pre-image. We know that x is at 1 and 4, y is at 1 and 1, and z is at 5 and 1. So here is our pre-image. Next, let's go ahead and dilate this. We know that because the center of the dilation is the origin, you can find the image of each vertex by multiplying its coordinates by the scale factor. So what I'm going to do is take my x value, 1 and 4. I know that my scale factor is 2, so I'm going to take each coordinate point and multiply it by 2. So if I take 1 multiplied by 2 and 4 multiplied by 2, I get that my x prime is at 2 and 8. Same thing with y. I'm going to take each coordinate point and multiply by 2 to get 2 and 2. And finally, z, 5 times 2, 1 times 2 to get 10 and 2. Here is my image after dilation. For part 2 of this example, we have to find the perimeters of the pre-image and the image. And in order to do that, we need to find the diagonal distance between xz and x prime z prime. Now, they recommend using the distance formula, and that's what we're going to use. However, if you notice that this is a 90-degree triangle, you could also use the Pythagorean theorem, a squared plus b squared is equal to c squared. So here we go. x2 minus x1 would give us 1 minus 5. y2 minus y1 would give us 4 minus 1. Simplify that, and we get negative 4 squared plus 3 squared. Further simplifying that, we get 16 plus 9, which 16 plus 9 is 25. Square root of 25 is 5. So our perimeter, we already have a value of 5 over here. We can find the other values of the sides by just counting the distance between each point. And in this case over here, we've got from x to y, we've got 1, 2, 3. So this distance is 3. And from y to z, it's 1, 2, 3, 4. So it's 3 plus 4 plus 5, which gives us a perimeter of 12 for triangle XYZ. For triangle x prime, y prime, and z prime, to find its perimeter, we first need to find this diagonal distance over here between x prime and z prime. We know that x prime is located at 2 and 8. And we also know that z prime is located at 10 and 2. So we're going to use these values, plug it into the distance formula, and simplify. So we get 2 minus 10 squared plus 8 minus 2 squared, which simplifies to negative 8 squared plus 6 squared, which further simplifies to 64 plus 36, which is equal to 100. Square root of 100 is 10. Find the perimeter of that. We know that one of the sides is 10. We still need to find the other lengths. Going from here, x is 1, 2, 3, 4, 5, 6. From x prime to y prime, we have a distance of 6. And then going from y prime to z prime, we have 3, 4, 5, 6, 7, 8. So we've got 6 plus 8 plus 10, which gives us 24. All right, checkpoint problems number 1, 2, and 3 are yours. In this, you are to use the dilation shown and then say, is the dilation shown a reduction or an enlargement? What is the scale factor? And what are the coordinates of the vertices of the image? All right, that's it from me. I'll see you all soon.